In this video, I'm going to show you exactly how to build your first custom Watercooled gaming PC, step by step, taking you from installing your CPU and components, all the way up to bending hardline tubing, understanding fitting types, setting up your loop, installing Windows, and launching into your very first game. This is everything you need to know. Special thank you to Corsair for sponsoring today's video. Okay, so we've just arrived at the Corsair London studio, and we're going to go check out the brand new 9000D, the new case, find out about the new features, and also some water cooling components that we can combine with it. The main reason why I chose to work with Corsair on this PC build is because these guys have everything when it comes to PC building and also water cooling. They have an entire ecosystem of products, all of the fittings that we'll need, the tubing, the tools to even cut the tubing, fans, RGB lights, RAM sticks, and also all of the CPU coolers and water blocks for the different components. This is going to ensure we have compatibility with everything we purchase, which was one of the biggest issues I had last time when I built in the Corsair 1000D case. I used other branded parts and components in a mix and match of different stuff that I purchased on the internet at the time, and it caused a lot of frustration during the entire build process and having to compromise in areas that I simply shouldn't really have to. This time around with the new 9000D, which is the updated and refreshed version of that case, we're going to be able to build the perfect water-cooled gaming PC because everything is definitely going to work with each other.
Yeah, so Ben, this is our 9000 series case. The full name is the 9000D Airflow. We call it a super tower case, so it's an absolutely massive case designed for the most ambitious builds.
What makes this so unique is the fact it is a dual system PC. Essentially, it allows you to have two computers in one case.
So you've got your main motherboard that would sit here, so that supports up to an extended ATX motherboard, and then down here you can have an ITX motherboard.
Perfect for having both a gaming and workstation combo, which is exactly how I use these cases. The 9000D is built for next-gen components. It focuses on current hardware and future hardware, letting me build the ultimate computer today, and then later down the line, it's very easy to switch out components because they're going to have compatibility. And with modern graphics cards getting bigger and bigger, a super tower like this is kind of perfect for anything that Nvidia or AMD throw its way.
So like an ideal way for you to be able to use this system is you could literally have it as your gaming rig through this motherboard here, and then down here is like the workhorse. So if you're doing streaming or something like that, you could have that as the separate PCs.
Now on Corsair's website, they do have a huge range of other cases that you can choose from for your dream PC build. And you can actually save 10% off all of these Corsair products that I'm going to show you in today's video by using the code BENROW at checkout. Okay, so let's go ahead and prepare the motherboards for this build. We've got quite a lot of work to do here because we've got two systems, obviously in a dual system here. So we've got the main setup with our AMD processor and obviously our secondary PC that's going to be rocking Intel. Let's first start with the AMD setup. This is going to be an ATX board with an AMD 9800X3D, one of the fastest gaming processors that you can purchase at the time of making this video. It's going to pair perfectly with my GPU of choice, but more on that later on. For the motherboard, I'm going to be using the Gigabyte X70E Aorus Elite Wi-Fi 7. When water cooling, it's worth investing in a higher-end motherboard and also future-proofing your entire setup. You're going through all the effort of installing the water cooling system, planning out the loop, bending all of the tubing. You don't want to then have to constantly be upgrading this. Like a year or two later, take it all apart, rebuild the loop, and put more components in. You want maintenance to be as simple and as minimal as possible. So this is the Corsair Light Enhancement Kit. Essentially, these are fake RAM sticks. I didn't even know these existed, but basically, you can put your normal RAM sticks in. So we've got our Dominator Titanium over here. We would put those in our normal channels as you would, 2 or 4, whatever it is on your motherboard that you've currently got. But if you've got 4 channels of RAM and you only need 2, you obviously usually have gaps within the motherboard, which isn't a big deal breaker, but aesthetically, you can obviously level this up and put some fake ones in. When you look at the finer details though on the actual connectors, you can see a huge difference in the layout between the two different stick variations. And then of course, when you look at the back, they've got different serial numbers on them and little stickers to say what's actually going on. Now in this build today, we're going to run 32 gigabytes of RAM in the AMD system and also in the Intel system. From past experience, I've done like 64 gigs and like excessive amount of RAM in the AMD stuff. But for the best gaming performance, this is probably the sweet spot. For the CPU cooler, we're going to go for the XC7 Elite LCD. This is available in black and white, and it's got some really cool features.
That's correct. That's the XC7 RGB LCD. So what you can do is with that, is you can literally have the temperature of the CPU or change whatever you like using the iCUE software system.
iCUE is Corsair's software that you install onto your PC after you've completed building it, and it's a dashboard that lets you customize all of the lights, effects, and features on the different Corsair products. So this is the XC7 Elite LCD cooling block for the CPU. We've obviously got our brackets here for Intel or AMD that we need to install. Cool thing about this is it's got an LCD display. So on here, we can show things like custom art design or whatever, but specifically probably the temperatures, what I'm most interested in actually displaying on this thing. I think that could look quite cool. So this is white to match our RAM sticks and obviously the case. So we'll go ahead and install this, and that motherboard is pretty much ready to go. These brackets operate on a toolless design. They simply slide onto the CPU block very easily, and they're secured into place. You then go ahead and present it to the motherboard, and then you grab a screwdriver and just tighten it up into position. With AMD motherboards, you don't need a rear bracket. You literally just screw it straight into the motherboard, but we'll talk about the Intel installation shortly when we do our ITX build. Okay, so we're going to install the CPU block. I think, though, I'm going to go ahead and put my own thermal paste on this. It does come pre-installed with like a cool triangular design, which seems unnecessary, but it's cool. I'm going to probably wipe this off, though, just to be safe, because we've got a bit of a beefy processor in here. And I'm going to throw some of my own on their little dot, and then we can attach this down. This step wasn't necessary on my end, but it's kind of bad habit that I have from back in the day. CPUs used to come included with a CPU block that didn't really have a great amount of thermal paste on, but these ones by Corsair would have done the job perfectly fine, and of course do help with that plug and play element of their entire ecosystem. Comes straight out the box, ready to go, and you just click it straight onto the motherboard, which I probably really should have just done, but I'm old school, I like to do everything myself. Overall, I think it's starting to take shape. So on the second system, we're going to be running another Gigabyte Aurora board. This means it matches, looks pretty cool. But this time it's going to be Intel powered on this actual computer. We're going to run the Intel Core Ultra 9 285K. Beast of a CPU. I've actually got it in that system over there as well. Most people don't really like this processor for gaming, which is completely valid. But when it comes to productivity, it's kind of insane, and it works nice if you want a bit of a hybrid system and you're not all about like the FPS like we are obviously on the AMD processor. For the secondary system, I have chosen the cheaper XC7 RGB Elite. This doesn't have the LCD display, but we don't need it because you're not going to be able to see it because it's going to be at the bottom of the case anyways, and the huge graphics card is going to be covering most of it up. Obviously, this is an Intel motherboard we're installing this onto, so we will need to use the rear bracket provided inside of the box. And I also suggest installing any of the iCUE link cables into your CPU block before you actually attach it to the motherboard, because you have the best access to these ports while it's in your hand and there's nothing obtruding or blocking it, such as the RAM sticks. So let's proceed with preparing the case and putting in our motherboards, and then we can plan out our loop so we know exactly what fittings we need and all the tubing. So let's talk about power supplies. In this build, I'm going to be using the Corsair HX 1500i. With a massive 1500 watt output, it means you can power any modern GPU, run multiple loops, and still have headroom for future upgrades. Fully compliant with ATX 3.1 and PCIe 5.1, and also includes a native 12-volt connector, so no sketchy adapters, melting cables, or compromises. So there will actually be two power supplies because we have got two systems. One's going to be an SFX power supply, which is slightly smaller. It's going to fit into the side for the ITX build. And then we're going to have a full-size power supply for our main build. We're going to need that as well because we've got a pretty beefy GPU with the RTX 5090 in this bad boy, so it's going to take quite a lot of juice. An SFX power supply is ideal for mini ITX or small form factor builds. The SF750 is a Gen 5 PSU, so it does have smaller connectors on them, and it's also modular, just like the HX 1500i. This helps control the cable management, reducing the amount of excessive cables plugged into the PSU. You only need to use the cables that you actually require for the build. I have also combined both of these power supplies with the Corsair cable kits in white to match the case, but you can get these in a large range and variety of different colors to help level up and add that finishing touch to the visual aesthetics of your PC build. Don't forget that you can save 10% on the official Corsair website on all of the products and components mentioned in today's video, simply by using the link in the description or my code BENROW at checkout. This could save you hundreds of dollars and pounds if you are building an entirely brand new computer from scratch. When we install the radiators, it's gonna block a lot of these cable trays that we've got here, so it's best to put these power cables into the motherboards because they're secured into the case right now, and then if we cover up any of these grommets, it's not a stress later on after we put all the tubing in and stuff like that. PC radiators come in all shapes and sizes, But what actually affects performance? First up is length. Longer radiators mean more fan slots, which means more surface area, and that equals more heat dissipation. Then there is thickness. A thin radiator like the Corsair XR5 at 30mm is easier to fit, quieter, and works great with low-speed fans. A thick radiator like the XR7 at 54mm delivers better thermal performance, but needs high static pressure fans to get optimal results, which can often lead to more fan noise. Next is fin density, or FPI. Low FPI at 10 to 13 is great for silent builds with slow fans, and high FPI 16 to 20 boosts performance but demands stronger airflow. Corsair strikes a balance with their XR series radiators using a medium FPI of 13 to 16, perfect for fans like the LX120 that hit the sweet spot between silent operation, strong static pressure, and rich RGB. I'm using the LX120s. These come in a variety of different sizes. These are obviously in white, RGB. These fans are really cool. They click together with magnets and they supply the power across them all by daisy chaining, so it reduces cable management at the end of the build. They then attach into the case super fast because of Corsair's one-turn screws. You literally do one full clockwise turn with the screwdriver and the fan is secured into place.
So we've got two versions of these. We've got LX and LXR. And the LXR is a reverse blade fan. So what it means is the fan blades are reversed so that you basically have like the nice side with all of the LEDs running on that side of it. So then all the way through your system, it all looks really, really nice.
Once you've installed the fans into the case, you plug them in all together with these iCUE link cables, and then you connect them to the master iCUE box, and they all communicate, link up with the software, and also are powered from this destination as well. So literally every fan in this system is powered by one cable essentially.
The whole way that it works is you've got this little adapter here that plugs onto the motherboard so that the CPU, like the BIOS, thinks that the CPU has still got a fan working on it. That's a USB connector which then plugs into the USB header on the motherboard, so that's how then the iCUE software then talks to the iCUE hub. And then here is just a power connector that then yeah, exactly, plugs into a 6-pin connector on the power supply. When we first launched this, we kind of had over-engineered it a bit and we're putting an awful lot of power through it. What we realized is if we lowered it down, we could increase the amount of devices that you can put onto the system. So this now supports 24 devices. So each device would be a pump, a like CPU pump, or a fan. So they would be all the different devices that then plug into the iCUE Link ecosystem.
The preparation of the case is coming together. We've pretty much got everything installed and we can proceed onto the next stage, which is actually planning and preparing our loop. We'll probably take some of these components back out when we actually construct the loop so we don't damage the graphics card or catch stuff on it. But for now, we've got everything in here, so at least we can see where everything's going to sit and where we might have some difficulties and collisions with where we might be putting certain pipes and tubing. Before I continue with the rest of the build, let me first explain to you how you actually bend a tube when you're water cooling. Obviously, you've got two different options. You can go for soft tubing or hard tubing. Each of these require their own types of fittings, which we'll discuss in that relevant section. But first, let me show you how you bend a hard tube, because this will influence your thought process when it comes to planning and preparing the layout of your own loop. So in order to bend the tubes, we're going to need a few tools to make this possible. First is a heat gun. This one's pretty good because it actually has like a flat bottom on it. So that means it can stand up, make it super easy compared to like one that you use if you like doing arts and crafts, sort of designed for water cooling. And then this is Corsair's Hardline tubing kit. I actually bought this around 2 years ago when I built my first Watercooled PC, and it made it super easy, especially for beginners. So inside of the kit, you get a saw for actually cutting the tubes. You also get this rubber insert, which helps retain the integrity of the tube itself when it heats up. I'll explain how that operates in a moment. Then you also get a table clamp to make it easier to hold the tube in place while you cut it. And then also this little sanding tool that gets rid of all the sharp edges on the tube before you put it into the O-ring and fitting to make sure that it is nice and smooth. So to actually bend the tube, we're going to use the rubber insert and put it inside of the hardline tubing. This is going to retain its shape and it's not going to fold in on itself. When it comes to the heat gun, we're going to set this to a medium heat, because if we have it too hot, it means the tube's going to heat up too fast. So we're just going to fail the bends every single time. We want to slow and steady, heat it up gradually, and then work within the heat and slowly bend it, slowly bend it. Show you how we do that now. So basically, we're going to go ahead and spin and rotate the tube. We've got the heat gun here firing up. We're going to have it slightly high up, not too close, so we're not like burning the tube. And we're just going to spin and rotate it like this, gradually heating up the attack point on the tube where we want the bend to happen. So we want the bend to happen here. We're just going to like spin and rotate it like this. Now, when you're using thicker tube like 14mm, This takes a lot more work to heat it up compared to the 12mm tubing that's a lot thinner. So this means you're going to spin and rotate it a lot more. You might have to go a little bit above the midpoint on the heat gun and turn it up a little bit, like a couple of clicks, just to get it workable. Otherwise, you're going to be here for absolute ages. So we're just going to work the tube around like this and just keep spinning and rotating it so we get like an even distribution of heat across the actual hardline tubing, like as follows. So the tube's finally getting up to temperature, and as I work it around, I'm gradually just gonna pull at it as I get the bend in position. Then I can feel the tube sort of working within the heat. So every time I'm rotating it, I'm just giving it a slight pull down. You can see how that is forming the actual bend point. And then we can do this to a 45-degree, 90-degree angle, whatever we roughly need. Now, as you become more experienced, you're gonna know what the angle is that you require, but you can also use little tools like this that basically are like guidelines, so you can put the tube in place, put it in there, and then you bend it to a perfect 90 or a perfect 45. It's worth like wasting a couple of tubes to get good at bending before you actually commit to your build, and this stuff's quite inexpensive, so it's not the end of the world if you use 2 or 3 bits of hardline that never make it to the final build. So once you're happy with your bend, it's worth just holding it and letting it set, basically let it cool down. So this is to hold it perfectly at 90 degrees, because if I let it go, it might go up a little bit or droop. So I'm just gonna sort of give it a little bit of tension, just let it cool off, and this will set the bend in place. And then once it's settled and you're confident it's pretty sturdy, you can just remove the tube. So you just give it a little spin and rotate out, and then you go use this on your next bend. Now that is ready to rock and roll.
When measuring and cutting the tubing, there isn't really a defined technique that you follow. You kind of just eyeball it and go off feeling. The way I approach this is I'll take a clean piece of tubing, I'll bend that straight to 90 degrees, 45 degrees, whatever angle I roughly need, and then I'll gradually trim the piece of tubing down. I'll just cut little bits off until it's the right length to plug into the O-ring and fitting that I'm trying to target.
What I prefer to do is, I don't like to cut it exactly to the centimeter of what I think's right. I prefer to give it just a little bit of leeway, and then I just gradually trim it down throughout the entire build. So I might take one piece of tube and cut it 3-4 times to just keep shaving little bits off before it's the perfect fit to actually go in. So we're going to use the table clamp, just put it at the side of the desk here, and let's just say figuratively we want it to be a rough, like equal distance on the 90 degree for however the PC's sat. We'll just put it into our little table clamp, and then we grab the included table saw, and you just literally trim away, and you just cut it down like this, and then that's it, cut to size. We would go ahead and do a little test fit, just roughly put it in position in the case, and then we might trim a little bit off if it's too long. Reason for this is if you cut it too close to where it needs to be, if it's then too short, there's nothing you can do. You just got to throw it in the bin, and you got to bend it all again and all that type of stuff. So it's best to always leave just too much on and just remove the excess gradually as you go ahead. Once it's finally ready to go in the actual PC build and you put a fitting and everything on it, you're going to use this little shaving tool to get rid of all these rough edges. So there's 2 sides to this shaving tool. You've got the outer of the actual tube, and then the inner shaver here. It's kind of like a sanding block. So basically, this is going to clean up the exterior of the tube if we were to put this in here, and we just give it a little spin and rotate, just like this. Super easy, we're just shaving it down. Then that's going to basically clean up the exterior of the tube and make this smooth. Then of course, the inside's got loads of cuttings and shavings in there. So this little pointed triangle is going to go inside of the tube and just basically clean up the inner. And then this just means the O-ring doesn't have anything, like there's all these dirty parts going all over the O-ring and stuff, and it just sits nice and flush. And then you just keep shaving that down until it's ready to go.
We now need to figure out where we're going to mount our reservoirs, and we've got a few options for this because of the size of the case. There's a few things to know when installing the HX D6 pump and reservoir combo. Everything in the box is included, and it's super straightforward to build. You get 2 brackets for installing this onto a radiator or fan, 120mm or 140mm for maximum flexibility. You can also mount these straight onto your case, depending on your preferred choice and where you actually want to put this. But make sure you don't forget to put the stop caps on any of the outlets that you're not going to be using. Otherwise, fill it up and it'll leak everywhere. So make sure you do this
before you proceed to the next stage of actually putting it into the case. So probably one of the best features of these XD6 reservoirs are the adjustable bracket. So this bracket effectively mounts onto a radiator similar to like a fan or a fan cover, and then you can loosen off the screws at the back, and then you can adjust that height up and down. This is going to allow for clearance for the 2 ports at the top. So then that way we can mount this into position, slide it up, and we've got access to the top for the inflow of the liquid, which is going to be absolutely perfect. When I did this style of build last time in the 1000D, we didn't use Corsair branded pumps. I used some different styles of reses, and they were res pump combos, and we had to mount them on the side with some DIY holes to mod the case. And that also meant it wasn't the most healthiest for almost the gravity being pushed onto the pump, because it was on its side. The liquid was on the side. There's a lot more pressure and tension on the actual pump itself, so it was running at louder levels. It was more vibrations and so on going through the case. This way, everything is going to be at its peak for the best performance and also acoustics. One final check I needed to make was the fittings to make sure that the door actually closed. The Corsair 9000D's got this new rail system for mounting your radiators and fans that lets you have full flexibility where you actually place it with this measurement. I'd maybe put it a little bit too much to the side, so it was pretty close to the door. And I was worried that the fittings on the res might collide with the door, so I'd have to move a few things around before proceeding to fitting the tubing. Luckily, everything fit perfectly. Now, when you're water cooling a computer, there's a bunch of different types of fittings that you're going to need to purchase to connect the pipes together, whether that be the pipes from the radiator to the CPU blocks, the GPU blocks, the pump. You're going to have some form of fittings that will essentially seal the liquid into the loop, and it's obviously not going to leak. Now, there's a bunch of different types of fittings that you can purchase. These compression fittings right here are simple ones for just straights, for basically putting things in and out of your radiator or CPU block. There's then drain ports, which is your drain valve for obviously removing liquid out of your system if you need to give it some maintenance or upgrade any components or switch out the coolant. Then, of course, you've got 45-degree angles and 90-degree angles. Depending on whether you're using soft or hard tubing, sometimes you will need to use different types of fittings for compatibility. For example, these are simple compression fittings for soft tubing, but they're completely different for hard tubing. So just make sure you purchase the right types. In addition to this, depending on how thick the tubing is, 12mm or 14mm, that will also dictate and determine which fittings are compatible with the size of tube. So make sure you get all of that correct when you're speccing out your PC. Now, inside of each fitting will be something called an O-ring, which is this little rubber seal. The way that we put this in position is super easy. We actually take our tube, we're going to take the top of the fitting, put it over there, grab our O-ring, which is going to go in between the 2 parts of the compression fitting, and then we just literally slide that into position, and then we would put the end of this tube, and that would like insert into it, and then we just clamp it down, and that will seal the entire loop. So you can see there we've got the O-ring going onto the fitting, then we just literally place that and present it, and just simply tighten it up, and that is our water cooling system completely sealed. So let me explain how you actually plan your loop. Right here, we've got our main reservoir. From the out of this reservoir, liquid will come out and run straight into the CPU block. From the CPU block, this will cool the processor and then bring hot water out from the CPU block and then into this radiator. The radiator will then cool this water up here, and then it will outflow the water back into the top of the reservoir. And this is a full cycle. It will just run in from the top, go right round through the block, up to the radiator, cool it, bring it back straight into the res, and that is a full loop. We then have this secondary drain valve here. This brings a nice long tube down to the bottom where we can then drain our system for any form of maintenance with the little drain valves at the back. Now, we do have an additional radiator in this case that currently isn't being used, and that's so I can upgrade the system in the future if I want to put the graphics card on water and I put that on a block and I want to cool that. At the back of the case, I do have an extra radiator that currently isn't ran into anything at all. It's just completely blank, but it's there so we don't have to take as much stuff out. The same concept applies to the secondary loop that's blue. Blue reservoir, water comes out, runs into the CPU block, cools the CPU, gets heated up, exits out
along this tube here, and it's ran into the radiator. It's plugged into the back right there. From this radiator, it's obviously then cooled, pretty overkill cooling. It's a big radiator for just the CPU. And then it gets flowing out from here back into the top of the reservoir, and then the process repeats. We've then got a drain valve located at the bottom down here with its own little port that we can plug in for any form of maintenance. And that is how you set up your loops.
We're going to use Corsair's performance liquid for the coolant in the system. Seriously, these guys literally sell everything for building a PC. It makes it so easy. It's a one-stop shop. We'll decant the big bottles into these small little squeegee bottles. This makes it so much easier for filling up the reservoirs. You literally just squeeze the bottle and it shoots the liquid up out of the nozzle that you can hook straight into the reservoir's fill port. We'll remove the motherboard's power cable and attach this jump start adapter. This comes included with the Corsair pump and reservoir. Last time I built my own PC, I had to buy this additionally on the internet. So this is cool. It comes with both the reses straight out of the box. We'll simply click this on and this will jumpstart our computer without actually booting up the motherboard, so we don't damage any of the components when we're constantly turning it on and off when we're flushing the liquid through the system. So now that we've got a little bit of liquid into the system, we're going to go ahead and jumpstart it. So we're going to basically turn the power supply on and quickly turn it off. That's going to flush the water through the actual loop that we've created, get any air gaps out of the way, and then obviously we want to switch it off as fast as possible so we don't run the pump dry, so it's like and it's not got any liquid there, because obviously we're going to flush coolant all the way through the system, fill up the radiators and all that type of stuff. So we're going to repeat this process multiple times. Fill it up, turn it on, turn it off, fill it up, turn it on, turn it off, until the reservoir's at a respectable level. Now, this is a vital stage in the whole PC build because you may have some leaks. So you want to check all of the fittings that are tight and also put any paper towels in position to ensure that it'll catch any leaks if they do occur.
Right, so we did have a leak on the outflow of the main reservoir, which was a bit of a stress. Luckily, it was a simple fix. Essentially, the tube just wasn't quite fully sat flush against its O-ring, so I think it had a little bit of a gap and it was leaking out fluid once the actual reservoir was under pump and there was load going on there and it was firing out that liquid.
This is also why I removed the graphics card while filling up the PC, because it's an incredibly expensive component. So even after this occurred, I went ahead and triple checked all of those fittings once again to make sure they weren't leaking, and also that those tubes were sat flush within the connector and they were sealed on that O-ring. Now, you can purchase an additional tool, which is the Corsair leak testing tool. That means you don't end up in this position like me, and I should have probably used this, but I was arrogant and thought I knew better because I was an experienced builder. So I'll leave a link down in the description to that, along with obviously all the other components that I've used in today's video. And don't forget to use that code BENROW at checkout to save yourself 10% off, because you're going to save an absolute fortune on a build like this.
Okay, so that was fairly straightforward. No other leaks anywhere else in the system. I'm now just going to let the system run for a little bit on constant loop. I've got enough liquid in the reservoir so it's not going to run dry and deplete fully down. And then once it's settled and leveled off, we can fill up the difference. We can top up that reservoir and put the seal cap on, move on to the second loop.
I'm going to repeat the exact same process for the second PC. We're going to attach the jumpstart cable to the power supply, and then we're just going to flush the liquid through the system continuously until that reservoir's at a decent level. Once this is complete, I'm just going to let both of the systems run continuously for around 45 minutes to an hour, just to make sure everything's okay, there's no leaks, and then I'll actually proceed to installing Windows and setting this up and connecting the cables back onto the motherboards. Alright, so now that the gaming PC is fully built, it's now time to do the final setup, which is installing Windows 11 and also all of the relevant software for maximizing the PC's performance. First, we're going to need to create a media installation tool with a USB stick. We can then install Windows 11 from this boot source onto our NVMe SSDs that are inside of the PC that we've built. This might take some time, so I'm going to leave this for now and come back and install my software later. Inside of Corsair's iCUE software, this is where we can tweak and customize our PC. This is an entire hub that lets you access all of the devices that are connected to the iCUE box, where we can change the color of the lights on the fans and also what's displayed on those LCD screens on our CPU cooler and also our pumps. You can see we've got a bunch of different presets for temperatures, even the time of day, and something really cool is actually sharing a YouTube video to these LCD displays and it'll actually play on the screen, which is kind of crazy. You can create different groups of iCUE devices within this software, where you can then tweak individual aspects of each product. Now, if you want to see how this gaming PC can perform and if it is capable of gaming at 8K, I pushed the graphics card to its absolute limit in this video here. You should watch that next, because if you like this, you'll like that.